3 similar triangles. What we're going to look at is the ways to prove similarity and then solving some problems with that. There are 3 ways to prove similarity. The first way is angle-angle. Notice there's only 2 angles. It does not have to be all 3. But in a triangle, if you know 2 angles, then you know the third. So it's really all 3 angles. So the 2 angles are congruent. The second way is side, side, side. In this way, the sides are not congruent. Remember, congruent means they're the same length. So in similarity, we have sides that are proportional. And this is all 3 sides. And the third way is side, angle, side. In this side, this way you have 2 sides are proportional. And it's not any angle. The angle has to be between the 2 sides. So one angle is congruent. So if we go over here and label this A, B, C, and this one D, E, F, we mark angle B congruent to angle D, then we have to say that AB over DE is equal to BC over DF. And remember, it was angle B was congruent to angle D. And notice B and D are in each of them. So our first problem, we need to determine if these 2 triangles are similar. So I'm looking at the triangles and I'm noticing that they give me 2 angles, so I'm going to probably use angle-angle. So I'm looking at it and 42 matches up with 42, so we're good there. But 58 is not equal to 80. That doesn't mean that it doesn't work. We always have to find that third angle. So we're going to go 180 minus 58 minus 42. When we do that, we come out that the third angle is equal to 80 degrees. So that means that angle A is congruent to angle E. So we need to write our similarity statement. So triangle A, B, C is similar to triangle, and A matched up with E, B matches up with D, and C matches up with F. So there's our similarity statement. We need to look down here and see if these 2 triangles are congruent. So if QPX, not congruent but similar, QPX is similar to triangle MXN. And how we do that is that we see there are no angles marked, but we can mark angles because of vertical, and we can also mark because of parallel lines. Remember, when you have parallel lines in a transversal, you have alternate interior angles, alternate exterior angles, corresponding angles, and consecutive interior angles. So we're going to alternate across the transversal and it's inside. So we have alternate interiors this way. And so that gives us angle-angle. So our triangles that are similar, our triangle QPX is similar to triangle NMX. And the reason is by angle-angle. A couple more. We're looking at this triangle and I don't see any angles marked. But remember, you have vertical, so we can mark those if we want. So we have 3 ways where angle-angle, side, 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 and side, angle, side for similarity. Now, angle-angle doesn't work because we don't have any sides marked parallel, so that doesn't work. So we are left with 2 options, side, 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 or side, angle, side. We can use either one of these. So as I'm looking at this, I'm going to go ahead and I'm going to write some proportions for my sides to see if it comes out. I'm going to do large triangle over small triangle. And the question comes up, which sides match up? So I'm going to make it real easy, and I'm going to look for the largest side, which is 9. And then I'm going to look for the largest side on the other one, 6. And then I'm going to go ahead and I'm going to look at the smallest side, which is 6, and the smallest side on the other one is 4. And then I can write the third one, but I won't need it. It would be 7.5 over 5. Now if I wanted to do it by side, 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 I would have to use all three of these. They all come out to 1.5 when you divide them out. And because they are all the same, that means the ratio is the same, the scale factor is the same, so they are similar. So triangle ABC is similar to triangle, and it was AB. Let's go ahead and put the C in the last spot. So A matched up with D, and B matched up with E. And how did I know that? Basically because, see the two sides I circled? One in pink and one in blue? The A was between it, and then the D was between the other one. So I figured it out as I went through and did these. So down here at the bottom we need to do the same thing. There's nothing on the third side, so the way I'm going to prove it is by side, angle, side. That's the only way to do this one, because you only know this side and this side. That's only two sides. Nothing about the third side. But we know this angle because it's reflexive, because it's the same angle. Now I've got to look at the big triangle, so I'm going to have to add up the sides to get the length. So this side is 25, and the length on the other side is 30. So I need to look at the triangles, MNP and triangle MRS. So MNP, the small one, and MRS, the large one. So I need to set up the ratios. I'm going to go small to large on this one. So I'm going to go 10 over over 25. Does that equal 12 over 30? And so you can either cross multiply, but I'm just going to go ahead and divide. And I'm going to get 0.4 is equal to 0.4. And so they are equal, so that means that they are proportional, so they are similar. So I can write my similarity statement. And the reason is by side, angle, side. So MNP is similar to triangle, and of course the M's match up, but it's MR and then S. Our next problem is just to tell if it's enough information to say that it's similar. So we've got triangle RST and triangle XYZ. We are given that two of the sides, the scale factor is 2/3. But what else do we need to know? Remember, our three ways to prove that they are similar were angle, angle, side, 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 and side, angle, side. So right now I have one side, so it's definitely not angle, angle. And this is only one angle, so this one doesn't work. I need two more sides. Well, this has two sides, but all I know is that the two sides are equal. It doesn't mean that they're equal to 2/3, so this one does not work. And this one doesn't work for two reasons. There's two sides equal, but notice they use the same triangle in each one of these. Okay, so this one does not work. And this one, they've said that all three are equal, so that would be side, side, and side. So this is the one that works. There's enough information there to know that they're similar. The next one, we have another triangle, two triangles, ABC and DEC. And we know that by vertical angles, these angles are congruent. So I've been given one angle, so I'm either going to use angle, angle, or I'm going to use side, angle, side. So I'll look down through here, and I notice this is the part that tells me about the angles. But notice this is a 1 and this is a 2. That means that they're not congruent, so this one doesn't work. Remember, angles have to be congruent. So that means angle, angle is not going to work. So we're looking for side, angle, side. So we need to know that two sides are proportional. This gives me one side on each equal to a number, so that's not enough. That's only one side. This one's given me two sides that are proportional. So AC and DC, and then BC and EC. That works. Check the last one. It gives me one side equal to a number, not two sides. Right here I want you to see that for similarity, reflexive, symmetric, and transitive properties work for them. Just that you can use that. There's no problem with that. So a couple problems. RS is parallel to UT, and that RS is 4, RQ is x plus 3, QT is 2x plus 10, and UT is 10. We want to find RQ and QT. So what we need to figure out is what matches up. They told us that the sides are parallel, so we know alternate interior angles are congruent. So that's enough to be able to write this problem. So I'm going to go small over large. So I'm going to go 4 over 10. Because this angle is congruent as well. So that means we just need to rotate it, and the 4 matches up with the 10, and the x plus 3 matches up with the 2x plus 10. So that's equal to x plus 3, the small triangle over the large triangle. Cross multiply. 4 2x plus 10 is equal to 10 times x plus 3. I'm going to go ahead and distribute. You get 8x plus 40 is equal to 10x plus 30. Go ahead, and 10 is equal to 2x, and x is equal to 5. We are not done. Always go back and check that you've solved for what it's asking. So it wants us to plug x back in to RQ and to QT. So RQ is equal to 5 plus 3, which is equal to 8. And then QT is equal to 2 times 5 plus 10, which is 20. This is the same type problem. The opposite sides are parallel, so we know alternate interior angles are congruent. All the information is in the picture. We're going to go this time large to small. And I'm going to go 38.5 over 11, because those sides match up, is equal to 3x plus 8 over x plus 2. Cross multiply. Distribute. And solve for x. You get x is 2. We are not done. It wants AC. So we need to just plug back into AC. We don't have to plug back into them all. So AC is equal to 3 times 2 plus 8, which is 14. Our last problem here. Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. So 12-foot light pole. The length of the shadow was 2 feet. So the shadow was 2 feet. He then measured the Sears Tower shadow, and it was 242 feet at the same time. So we want to know the height of the Sears Tower. So I'm going to go the object height over the shadow. And because it's at the same time, you can tell the height of something by doing similar triangles, because the sun is at the same angle. So the 12-foot pole, put that on top, and the shadow at the same time was 2. That's equal to, and we don't know the height of the Sears Tower, so we're going to make it x, but the shadow was 242 feet. We're going to cross multiply. 12 times 242 is equal to 2x. And it comes out that x is equal to 1,452. So the Sears Tower is 1,452 feet tall.